Give it just a couple of seconds. I had to restart the stream because the let me turn this volume down a little bit. I had to restart the stream because YouTube didn't pick up all my cameras. So here we are. Let me turn this thing off for a second so I don't have to yell. All right, hey everybody. It's been a little bit of a hiatus again. We were trying to start up doing the weekly live streams, like 2 months ago, almost. We did a couple of them. I went to go do another one, and YouTube would not let me go live. Put in a whole bunch of tech requests to YouTube about it. It took them about a month and a half to get back to me. Apparently there was like a document that I needed to sign that said I basically wouldn't like be naked on the camera on a live stream. Was more or less what it was. So nobody wants to see that. So yeah, that's not going to happen, unfortunately for you guys. But we got that notice signed, so I can guarantee you there's going to be no nudity on the live streams. Thank you, YouTube, for delaying me for like 2 months. So anyway, we've got some things to do tonight. This is our dual scan laser gun. We can briefly go over that, but we're going to do dual scan, single wire feed, aluminum. And then I've got our dual wire feed set up. You can kind of see it over here. That's our dual wire feeder. So I've got it set up. We're going to do some dual wire feed on stainless tonight as well. So I'll switch machines. It'll only take me a couple of seconds, but yeah, we're going to be back now, finally. Anyways, let's go ahead and get started. We'll explain the difference between the dual scan gun and our single scan gun. So here we have the dual scan, here we have the single scan. They're about the same size. This one does look a little bit bulkier in the back, but overall, the overall size is about identical. Side profile. This one's just a hair wider, but overall they're the same size. So what this single scan gun does, we have a single reflection mirror here in the back of the gun, and it scans the laser side to side. So it only scans in one dimension, left and right, that's it. With the dual scan gun, we have 2 reflection mirrors inside this gun, and they're angling the laser different directions. So what we can do is we can scan in dual scan, so 2 scan. We can scan in 2D, so we can scan fore and aft and side to side. So that's where we get our laser like wobble shapes, which we'll show you here in just a second once I get this thing fired up. But both guns have their pros and cons. The single scan gun is a lot better for cleaning. You can get up to a 120 millimeter wide cleaning path. With the dual scan gun, you're limited to only 40 millimeters wide, but you do get some different cleaning options. The dual scan gun does come with some like easy set mode, so you can basically select your material type, your material thickness, manual wire speed, but the laser will kind of set itself up and get you close using their power set, our power set mode. So let's go ahead and get started. I don't want to talk too long. Let's just get into welding. Let me go ahead and turn this thing on. Got our gas. I'll show you guys the controller for this thing real quick. So pretty simple. We've got our gas there so we can check our gas. This is our wire feeder so we can turn it on and off from the remote. Wire feeder off, wire feeder on. This arms our laser, so now we are armed. We can see our connect light here. I do have the gun resting on the table. So as we set that down, now we have connection. So very similar to the single scan gun. Where we get into differences, we can select our material type here. So aluminum, we've got some 1/8" coupons we're going to do. That's basically 3.2 millimeters. So we'll set it to 3.5 millimeters. And this will spit out like a generic, like starting parameter for us. So we can actually see that here. So this is the shape that we're going to have. This is our scan frequency, how fast it's moving around that actual scan. And this is our width, power, pulse width modulation. We don't need to change that. And then duty cycle is always going to be 100%. So there's the settings. I'm running 045, 49, 43 at 50 centimeters a minute. Let's go ahead and tack a couple coupons up and show you guys what we got. We'll play around with the settings just a little bit just to show you guys the differences. Tack up a fillet weld. Let's tack up a butt weld. Oh, that non-penetrating laser just burns right to the table. So here we go. Let's we can get on the arc shot cam. That'll light up once we get started. You'll be able to see a little bit better. Oh, there we go. So you can see we had kind of that D-shaped wobble. See if you guys can see it. So you can actually see the laser scanning around. I got the wire in the way, so it's going to be a little hard to... Camera doesn't quite pick it up, but we have a D shape is what we're working with at the moment. There's a little fillet weld. Let's do a butt weld real quick. Oh, I slipped a little bit there. That's a user error. Oh man, these lasers just don't penetrate at all. Gotta pry stuff off our backing plate. So we penetrated right down to our copper and we welded that to our copper. There we go. So get a little close up. So of course I skipped a little spot. I slipped, my hand slipped right there, but that's full penetration. Nice flat bead profile. So if you were going to have to grind this, you'd have very, very little to grind. Let's do another fillet or another butt weld real quick. But what we'll do is I'll have this resting over the top of this gap here. That way we can see that penetration fully and we don't weld it back to our copper. Just so you guys can see too, tight butt weld. Well, there's a little bit of a hairline gap there, but basically tight butt weld, no gap. That might be a couple thousandths at the most. Anyway, here we go. So there we go, full penetration. A little toasty. So let's do another fillet weld real quick. Let's see, we'll tack this up. I can get you guys a little bit better arc shot of this. There we go. Well, we got Oleg in with us tonight. He's been harassing me enough about getting started back on these, so it's good to see him in. So yeah, real quick and simple fillet weld. We are going to send a couple samples over to Aaron at 6061. There was another, let's call it laser company, that had made a pretty poor example of laser welding. And there's been a couple channels lately, not to name names, but there's been a couple channels lately that have made some pretty bad excuses for laser welding videos. But I want to dispel a couple of those myths, so I'm actually going to weld up a couple samples here tonight, and then we're going to send them off to Aaron for comparison. But no, I think the video that he was watching, the guy really didn't know what he was doing, or how to set the machine up. For example, you can see we are actually fully penetrating this joint. So that's the backside of our fillet weld. We've got real nice full penetration there. Lot different than the videos that have been floating around. Is the laser going to replace TIG and MIG? In some situations, yeah. It's just like, when MIG welders came out, they replaced some things that were being done with stick. So yeah, the lasers are going to replace some MIG and TIG applications. I'd say, like, right now, the way the industry is, the way the guns are, anything under 1/4 inch, especially stainless, anything under 1/4 inch that's stainless production work, is probably going to start going towards laser in the next 4 or 5 years. It's so much faster. It's so much easier. It requires a lot less skill. So for a company that is looking to expand their production and they can't find good TIG welders, The laser, I mean, I can literally take someone having never seen a laser welder at all and having them turnkey ready for production in about 4 hours. And that's like troubleshooting, safety, how to set the machine up, how to diagnose their welding issues, you know, turnkey ready for production in about 4 hours. And so if you had someone new to TIG, you're not going to have them turnkey ready for production in 4 hours. 4 weeks, if they already had some TIG experience, maybe. Uh, MIG, probably about the same. Stick, about the same. So that's the one thing with the lasers. It has a very steep learning curve. I mean, you go from knowing nothing to being extremely proficient. There's a large step there, but it's very short. So it's a steep learning curve, but it's a very short learning curve as well. Yeah, I think for like mobile wise, the setup's pretty big, Rick. So the setup for lasers is pretty big. Even here, I'll zoom out. Let me get our arc shot cam out of the way. So this is going to be like looking behind the newscaster desk. I'm in shorts and flip flops, so safety Nazis, I don't want to hear it. Anyway, Rick, here's our 2,000 watt air cooled setup. So this unit here weighs about 135 pounds. The wire feeder weighs about 25 without a spool of wire in it. So it's not going to be the easiest thing to take mobile. I travel around with them quite a bit, throwing them in the back of like my Honda Element. So for stuff like that, they're just not that portable yet. We do have a unit actually right here. So that unit back there is actually our 1250 watt laser. It is a lot more portable. It's obviously a lot smaller than this big guy right here. It's a lot smaller than that unit. I don't have the top handle on it. Let me get out of the way. I don't have the top handle on that one at the moment, but it does have a top handle like our Cyclone MIGs. I'd say it's a little bit taller than like a 262 Cyclone, but it's a little shorter, but it weighs about the same as a 262 Cyclone. So yeah, I'd say conservatively in the next 4 to 5 years that the lasers are going to take over a lot of your production, like MIG and TIG work on thinner gauge stuff. Anything under 1/4 inch, I'd say it's coming. There's the aluminum welds aren't as aesthetically pleasing as TIG, so there is some challenge there. If it's something that needs to be, really aesthetically pleasing, the laser's not going to be the best choice. But that's one of the things when I'm talking to people and I'm, talking to them about a laser, and they're asking, where it fits, and there's a box that the lasers fit in, and when you're operating inside that box, they work extremely well, better than just about anything. So, one of the things I say when I'm like on a sales call is you're not going to TIG weld up a skyscraper the same way you're not going to stick weld a fabricated 9-inch rear end housing. The same thing with the laser. The lasers aren't ready to build a skyscraper. Not going to use them for thick, heavy structural stuff. Where they are good is they're not good for really super tight areas. Like these are some samples I'm running, for a customer here that does sign work. The lasers do not fit down in here very well. I can do it, but it takes a little bit of practice. So stuff like this, if you're doing production, it's not going to be you buy a laser and you're hammering these things out in an hour. Like it would take some time to learn how to do these. It's not the best fit. But if we are, let's say we're building like, food prep tables, food service sinks, stuff like that, the laser is a godsend. I mean, you're looking at 6 to 8 times faster than TIG. It's more consistent than TIG. It's easier for someone to run than TIG. So there's a lot of benefits. You just have to be inside that box, and that's like every other process, though. So it's not like the lasers are going to come and take over every single process. Every process has its area, and That's it. The lasers have an area where they work extremely well, better than anything else. And in those areas, the laser is going to take over a little bit. So we got Aaron on here now. So Aaron, I'm going to go ahead and run. I'm going to run. Let me grab 2 more coupons. I'm going to run a couple for you right now. And I'm not going to clean these or degrease them or anything. So I want worst case scenario for the laser. And again, we're not using any special settings. We basically just selected the dummy mode, and that's what we're running. We're running the dummy mode. So no trick setup, no fancy settings. You know, no laser black magic. We're just turning the machine on, putting in our material thickness, and we're running what the machine tells us to run. There we go. There's one. I'll mark these, Aaron. What I'll do here, just so everybody can see that there's not a trickery. Put 3 little dots on them. That's a cold one. All right, let's do one more. Then we'll go back on some of our other pieces, and I'll kind of show you guys what some of these other scan settings do and how they change the bead profile and how the machine runs. So let's see, we're going to try to get that. That'll give you guys a pretty good view from the start. Yeah, Oleg, this is the dual scan. This is the dual scan 2000 watt air cooled unit that I'm running. You guys can see the scan in there. Yep. There you go. Yeah, and Aaron, I don't know if you caught it, but here's the penetration from a tight butt weld. My hand slipped a little bit right where that nasty spot is, but full penetration. Full penetration on 1/8 inch. Let me grab a couple more of those real quick. We'll just use these. So what we're going to do now, let me get this out of the way. So like I was saying, we've got a couple different options as far as like our scan frequency. So what I'm going to do now, let's go. So now we've got an hourglass shape is our scan, and we're going to go up to, let's go up to 8 hertz. So we're going to do the same scan width, the same scan width, same wire speed, same wattage output, same wattage frequency, or our laser output frequency. So all we've changed is literally our scan type and our scan speed. That's it. And so let's do another run real quick, and we'll show you how much different they are from each other. So real quick tack. There was another YouTube page that just did a laser video a couple days ago, and I think you'll notice they're sticking the wire every time they run. They stick the wire, and what that is, it's poor setup. It just shows that whoever is setting that machine up and running it does not know what they're doing. So that's a big problem. We might actually talk about having having Aaron come in here and do some laser welding with me. It'd be a lot more convenient than trying to ship one of these units. So let's get over to our arc shot cam again. I'm going to send you guys on a ride for a second, so let me get out of there. There we go. All right, arc shot cam. So we'll see if we can see this. So now you'll see my laser shape is kind of there we go, an hourglass shape. So we went from a D shape to an hourglass, and you guys will be able to see a pretty significant difference on how this runs. So again, you can see that we've got the full penetration right there from our butt weld, but you can see that full penetration from the fillet weld. I know, Aaron, that was one of the things that was not present in the video you were talking about. So it's operator error. They didn't know what they were doing, and they really showed it. But yeah, super nice, smooth bead. Let me grab another coupon. Let's do an outside corner real quick, and we'll move on to some dual wire stainless. Let's flip this over. So there we go, nice and easy to tack up an outside corner. We'll just run it just like that. So we've gone back, well, let me tell you. So we've gone back to our D shape. I've gone back down to 2 hertz. I'm actually going to speed that up to 4 hertz. And I'm going to, since we have on our joint, we have kind of a natural groove there. So our joint is actually wider than when we're doing like a butt weld. So what I want to do is I actually want to widen out my scan just a little bit so it catches these edges a lot better when we're going down. It'll give us a more rounded profile to our weld instead of just a angle, flat weld, and then angle. If we widen that scan out and we really catch those edges, we can get a more rounded profile to our outside corner. Everything looks good there. Arc shot cam. I try to keep my hand out of the way of the camera. I got a little off track there at the start. Here's our outside corner. I missed it a little bit right there, but that's operator error. Yeah, outside corner. And then there's our penetration. So that's a dual scan laser. Where are we at time-wise? 30 minutes? Perfect. So let's turn this one off. I'm going to unplug it, plug in the single scan 1500. I'm going to swap my gas. There we go. Now we're set up on our single scan 1500 watt unit with the dual wire feed. So with our dual wire feed, we can run single or dual wires. We can set up two different spools. So we could have a spool of aluminum and a spool of stainless in it. And then all we have to do is swap this little arm for the liner. That's all we have to do. Let me get out of the way. So there, we just have this liner for the wire. We just pull one bolt and then we can hot swap between different materials without having a bunch of setup. So whether you're running a single wire or a dual wire, the dual feeder is pretty nice. It does help out quite a bit. All right, so let me change my... All right, there we go. So we're running some 065 stainless. I'm running twin 045 wires. So we are running quite a bit of wire into this. Running about 800 watts at a 4.5 millimeter wide scan, 300 millimeter a second scan speed. We're going to run continuous wire with continuous laser power. So just real simple setup. I'm going to trim this wire back just a touch. There we go. There's our constant power, constant wire feed. Right now I'm running about 30 centimeters a minute wire feed speed with this 045 wire. And just to give you guys a close-up of what that looks like. So we do actually have two wires running parallel out of the end of the gun. So now let's rig up another one real quick. What we're going to do, we're going to turn on our laser pulse. So now instead of that constant, we're going to have a, we're actually going to be pulsing the laser power on and off and leaving our wire speed continuous. And what this is going to do, it's going to cool the weld down a little bit so we can go up on wattage. We could go up another, let's just go up another 100 watts. We're going to leave everything else the same other than turning on our laser pulse. So let me tack those up real quick. Oh, I might have burned up my focal lens or my protective lens. No. Oh, I put it to 100 watts, not 900 watts. There we go. Operator error. Again, one of the other things I was saying, notice how I don't stick my wire. It's all set up. It's just all set up. That's all it is. So if you're seeing someone running the laser and they're sticking the wire nonstop, it's simply they just don't know how to set it up. I mean, there's no other way about that. So there we go. Just got a little color on the back side, no sugar. Even on the bottom, just a little bit of color, no sugar. And then our heat, just dead on perfect. And it's a real tight, almost like a lay wire pulse TIG bead is what it looks like. So let's run a butt weld real quick, kind of get you guys in on the arc shot cam to see what's going on here a little bit better. We can actually, let's go back and turn our scan speed down. So we've ran 300 millimeter a second scan speed at 4.5 millimeter wide scan. Now we're going to a 90 millimeter per second scan. So it's going to really slow this scan speed down a lot. So our side to side movement. And what that's going to do, it's going to allow that laser to have a longer dwell time across the middle of the weld, and it's really going to burn that wire in a lot better. So shiny, it's almost hard to get a good view of it. We're going to run more fillet weld, just so we'll turn that laser pulse back off. Let me tack this up real quick. We'll get on the arc shot cam again. Now the sparks are just from the laser scanning back and forth, scanning over the wire. It sparks a little bit, but probably looks more dramatic on the arc shot cam. So now we're running constant power, but we're running at slower scan speed, so we have a slower scan side to side. And I mean, you just really can't beat the way. Let's see if this flashlight helps. I mean, it's just such a pretty weld. And with this dual wire, you get a lot higher deposition rate. So when you look at the side profile of the weld, instead of being, concave, you get a very flat, like what you'd want to see out of like a typical TIG weld. You get a very flat weld throat instead of having that real concave weld that you'll see a lot with the lasers if you're running single wire on something this thick. Even running our, I think I have it right here. So one of the things I get asked quite a bit is how thin will the lasers weld? And so here we go. So here's a set of razor blades. This was the second attempt I ever had on the razor blades. Of course, we've got, it's real easy to get full penetration, but that's running a single 045 wire. So if we even went down to 035, I think I could get that cleaned up quite a bit. But so that was my second attempt ever on doing razor blades. Let's do a lap weld real quick. I don't see a lot of people doing lap welds. It's hard for me to hold that in place because I'm left-handed. That'll be all right there. So we go super flat weld. We got a real nice, it's kind of hard. The camera won't focus on it. Just a really nice, you'd be hard pressed if you didn't know that was laser welded. You'd be hard pressed to, not think that was a TIG weld there. So yeah, Rick, actually I am wearing our laser welding hood that we're going to be having in stock here in it's like another week or so. We should be having these come into stock. Here, let's do a close-up of it. Let me zoom out. So it does have the metal, front face protection. And then I got terrible lighting in here. But it is an auto dark hood. This hood is actually good for regular, like your arc welding processes like MIG, TIG, and stick. But this is rated for laser. It's a shade 4 to 12. You can set it into a dark state only at a shade 16. This is an OD plus or an OD 8 plus for 1070 nanometer, and then for over 1100, it's rated an OD 10 plus. So OD 8 plus under 1100 NM, and then over 1100, it's an OD 10 plus. So super awesome hood. Those are going to retail right at 600, 650 is going to be retail on these. So about half the price of anything else on the market. This hood is going to be made by a company called Techman. If you don't know, Techman makes all of the Viking hoods for Lincoln. They also make all the Sentinel hoods for ESAB. So Techman is a really well-known company, kind of behind the scenes. They do a lot of private label stuff, but just in the interest of full disclosure, this hood will be made by Techman. Super good company. They've been awesome to work with. We are also going to carry a new TIG hood from them as well. I've been using this thing. I've kind of had, so this is my Selstrom WHP 4000. This was kind of my go-to hood for the last 7 or 8 years. But honestly, since the Techman hood's going to be about half the price of the Selstrom, it's got the same size viewing screen. It's got all the same options. It's got 4 sensors on it. It's an awesome hood. And I've been using this since FabTech Orlando. It's been my go-to since then. Yeah, they're awesome. What shade do I prefer? So I use that on a shade 4. I've also got brown eye, like super, super, super dark brown eyes. So even like these glasses that come with the units, they're a little bit too dark for me. Let's see if we can. So these are the glasses they come with. They're about a shade 5. I find for me personally that these are a little dark when I'm trying to tack stuff up. I can't see that well with them. They're not bad. It's just, they're just, it's just a little dark when you're tacking up. So that's why I do like the auto dark. It has a light state of a shade 2. And I use it on shade 4. And I mean, I can weld like that all day with it, and I don't ever get spots. So it's not really about the darkness of the hood. That's all personal preference. The main thing with like either laser glasses, a laser rated face shield like this. So this also comes with the units now. It is a little bit lighter. It's about a shade 3, I'd say. These are a little bit light to weld in. But with laser rated eye protection, you've got a couple things you're looking at. So you have the wavelength of the laser. So you need to make sure that the glasses or hood are rated for the wavelength. And then depending on the wattage, you need like OD5, OD6, OD7, OD8. And what that is, it's optical density. So like a 1500 watt laser, you need like about a 5.8 plus optical density glass. So these are rated for the wavelength. They are rated for the laser output. And then they're about a shade 5 is what they are. So those are the two things you're really looking for. Not really shade, but you're rating for the wavelength, and then you're rating for the optical density for your wattage output. So if we're looking at like a 3000 watt laser running it wide open, we are going to be around was like a shade. It's or not a shade, but OD8, OD7. I'd have to look at the exact calculations again. But yeah, that's about it. I said I just wanted to run through a couple different options. We hadn't had any videos yet with the dual feeder. We hadn't had any videos yet with the dual scan gun. So I just wanted to get those out there real quick. We are going to be doing another film session, not Easter weekend this weekend, but next weekend. So the following weekend, we are going to be doing another big film session. We've got, let's see if you guys can see him in the background. Not really. I've got him hidden behind the weld booth. You can kind of see, right here. And then you can kind of see behind this table. We've got a couple prototype machines that we are going to be doing some videos with. We've got the new 255 Thunder. We've got the 215 Thunder. We've got the 253 DPI, the LCD display, the new version that has synergic pulse, single and dual pulse MIG, so it makes setting up the single and dual pulse a lot easier. It does have the power set mode on it now. And then we have the new 263 PI, which is basically a 262 Cyclone, and we've added single pulse to it. So we'll still have the 262 and we'll have the 263 PI. So we'll run through those. We'll run some, like the live stream. We'll do some live stream videos with them, but we're going to have a film session with them next weekend after Easter. So there'll be some new content coming out with those for people that have questions about them. Other than that, yeah, that was pretty fun again. I kind of miss doing this. But Aaron, if you're still around, I'll get those samples out to you. I'll get with Oleg and we'll get them out to you. I'll send you some more butt welds like stainless and aluminum. We're going to try to run some 1/4 inch and 3/16 for you as well to do some comparison. So anyways, guys, I appreciate it. We had quite a few people in here for a minute for just kind of a spur of the moment, no announcement thing. So again, we're going to be kicking up, doing the live streams every Thursday at 7 p.m. Central Time. So yeah, if you like hanging out, you want to ask some questions, join me. Till then, have fun, guys. Be safe. Don't shoot yourself with lasers. They hurt. And always wear your eye protection. Have fun.